Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study and solve the problems based on the maximum height of your projectile on your horizontal plane. Okay, in previous session, we covered equation of your trajectory. From that equation, we calculated the time of flight and the horizontal range of your horizontal plane. Now the third component was left yesterday and going to be solved now, derived that expression, that is the maximum height of your projectile on your horizontal plane. Here the vertical component of the initial velocity of a projectile is u sin alpha and the horizontal component is u cos alpha. At the maximum height, suppose if we consider a projectile is moving in the shape of a parabola, okay, and reaching the point ground at A, point A, and it is the point P is the maximum height. If the particle is at this point and this particle is having horizontal and vertical velocity components, that is ux and uy. This uy vertical velocity component, the magnitude of the vertical velocity component is going to be decreased and becomes 0 at the maximum height. At this point P is the maximum height where the ux exists, whatever uy, that becomes 0. When it comes to downward direction, here from O to P, it is in upward direction. The projectile is in upward direction. When P to A it comes, the projectile goes downwards. At that time, the velocity component, vertical velocity component become downward direction, but the horizontal component of velocity remains same. The direction and the magnitude of the horizontal component of the velocities remains the same throughout the projectile path, that is OPA. When it comes to UI, the UI becomes maximum and UX also will be there still existing. Yeah, it is landing here. Now, the point is that the vertical component of initial velocity, that is here the making angle alpha, that means UY equal to U sin alpha, whereas the horizontal component of the initial velocity of the projectile is U cos alpha. But at this maximum height, the vertical component of the final velocity that becomes 0. And next, the average velocity of this 1 and 2, that is u sin alpha plus 0 by 2, that is u sin alpha by 2. That is the average velocity. Now, the height, we are going to find out the maximum height, and we are going to consider let h be the maximum height reached by the particle, and time t be the time taken by the particle to reach the maximum height to attain the 0, that is the sin alpha, that is u sin alpha, to attain 0 velocity from u sin alpha, and also that the time taken by the projectile to reach the maximum height, that is u sin alpha by z. The time taken to reach the maximum height, that is u sin alpha by z. Now, whereas the maximum height of the projectile h equal to average velocity times time. What is the average velocity? That is u sin alpha by 2, that is the average velocity, times the time. The time is u sin alpha by z. If you multiply, that becomes u square sin square alpha by 2z. This is the derived expression, the expression for maximum height calculation of the projectile on your horizontal plane. So u square sin square alpha by 2z, the maximum height h maximum equal to u square sin square alpha by 2z. What is the u? Where u is the initial velocity and alpha is the angle of inclination or angle of projectile. The alpha is the angle of projectile, where g is the gravity acceleration. Now let us going to be solve this problem by using this expression. We are going to find out the height of a bullet, how height the bullet will rise. So your bullet is fired with a velocity of, what is the velocity? 100 meters per second, and the angle of inclination is 45 degrees with the horizontal. how much height the bullet will be raised. So how much height, the maximum height, h maximum, the maximum height equal to, that is u square sine square alpha by 2z. We know the u value, the u is the 100 meters per second, u equal to 100 meters per second. And where is alpha, the angle of inclination, the angle of projectile, that is 45 degree. Substitute over here, that is 100 square times sine square alpha. What is the alpha here? 45 degree by 2 times z, 9.8. Now we'll get the how high the bullet will rise. Now here, now the velocity of the projection, that is 100 meters per second, and the angle of projection with the horizontal alpha equal to 45 degree. This is what here we have to solve. The maximum height to which the bullet will rise, that is u square sine square alpha by 2z, that is u equal to 100 and alpha equal to 45. Substitute over here, and the obtained height is 255.1 meters. So with the velocity of 100 meters, okay, 100 meters per second, and the angle of inclination with 45 degrees, if we fire the bullet, then what will happen? It will reach the maximum height. The maximum height it will reach is 255.1 meters, and before going to land, here 45 degree with the velocity of 100 meters per second, the bullet will rise. How much here it is? That is 255.1 meters. Okay, and the next problem is that we are going to solve one more. We are going to apply this. If a particle is projected inside a horizontal tunnel, if a particle is projected inside a horizontal tunnel which is 5 meters high, which is 5 meters height, with a velocity of, what is the velocity? 60 meters per second. Find the angle of projection and the greatest possible range. What is the angle? Alpha, and the range r. We need these two things. But what was given here? Here that 60 meters per second, that is the okay velocity, and is the 5 meters height given. Yes, find the angle of projection and the greatest possible range. So the height of the tunnel, that is 5 meters, and the velocity of the projection u equal to 60 meters per second. Now let us apply the angle of projection we need first, and also greatest possible range also. So the maximum height equal to height h equal to u square sine square alpha by 2z. We know the height h, that is 5 meters initial velocity, with which the velocity u equal to how much here? That is 60 meters per second, 60 square sine square alpha by 2 times z, 9.8. From that unknown can be calculated that alpha is the angle of projection. Okay, let us see here. Alpha is the angle of projection. Height h equal to 5 meters, u square sine square alpha by 2z, that is 60 square by 60 times whole square sine square alpha by 2 times 9.8. That alpha equal to, that what is the angle? 9.5 degree. Alpha equal to 9.5 degrees. Okay. Alpha equal to 9.5 degree. That is the first objective. That is the angle of projection. The next is the range. What is the greatest possible range? The range value, we know that u square sine 2 alpha by z. Range r equal to u square sine 2 alpha by g. What is the u? What is the u? We know u equal to 60, and alpha is obtained here 9.5. That is 60 times 60 whole square sine 2 times alpha, 9.5 by g, 9.8. That is the range can be calculated. Okay. Now the range, the greatest possible range, what we discuss here, r equal to u square sine 2 alpha by g. But u equal to 60 whole square sine 2 times alpha is 9.5, which is came from this alpha came from the maximum height calculation, then 9.8. Then u square sine 2 alpha by z. If we substitute over here u and alpha, the obtained range is 109.6 meters. 119.6 meters. Okay, that is the range. And before we calculated alpha 9.5. Now here the range is 119.6 meters. So these are the two objectives are asked here, calculated. Okay, and next step, what is the next one? The next model, the next problem is that a body is projected at such an angle that the horizontal range is 3 times the greatest height. U square sine 2 alpha by g, that is the range, and height h equal to u square sine square alpha by 2z. This is u square sine 2 alpha by g range, and height equal to u square sine square alpha by 2z. Now what they did, we have to find out the angle of projection alpha. The angular, the horizontal range is 3 times the greatest height. What is the horizontal range? Is 3 times. Horizontal range r equal to 3 times the greatest height, 3h. By using this relation, okay, what is the range? U square sine 2 alpha by g equal to 3 times u square sine square alpha by 2z. By using this relation, g get cancelled, u square get cancelled. From this alpha to be calculated, sine 2 alpha can be written as 2 times sine alpha cos alpha. That equal to 3 by 2 times sine square alpha. Again, one sine alpha will be cancelled. And what happens? 4 times cos alpha equal to 3 times sine alpha. And sine alpha by cos alpha it goes to right hand side, and below the term of sine, then sine by cos, that is tan alpha equal to 4 by 3. That 4 by 3 means 1.33. And from this alpha can be calculated. Thus, we can calculate the angle of projection. Okay, let us check the solution which was given in the textbooks. Yes, u square sine 2 alpha by g. Another one is u square, that is the range equal to u square sine 2 alpha by g, and height equal to u square sine square alpha by 2z. Now the horizontal range r equal to 3 times height. The next step, substitute over here, u square sine 2 alpha by z equal to 3 times u square sine square alpha by 2z. Height u square sine square alpha by 2z, and whereas the range u square sine 2 alpha by g. Okay. Now, if you substitute here 3 times height, u square got cancelled, sine alpha, 1 sine alpha got cancelled, g, then what left? 2 times cos alpha equal to 1.5 sine alpha. The tan alpha equal to, as I mentioned, 1.33. Then alpha equal to tan inverse of 1.33. That is 553.1 degree. That is the, what is that? Angle of projection when the range is 3 times the maximum height. Now suppose in some of the problems, range u square sine 2 alpha by g and maximum height u square sine square alpha by 2z. Suppose in some cases the range, horizontal range equal to 3 times the maximum height. Then in that case, 3 times in that case, what is alpha? What is the angle of projection? Now, the angle of projection, what is the angle of projection? That range is, what is the range? Is u square sine 2 alpha by g, u square sine 2 alpha by g equal to 3 by 4 times u square sine square alpha by 2z. Now make it calculation, gg, and make it again 2 sine alpha cos alpha, u square get cancelled, then 2 times sine alpha cos alpha, then 8 by 3, tan alpha equal to 8 by 3. From that alpha will come out. Okay, that is the case for like that. If anybody, our range u square sine square alpha by g, range formula u square sine 2 alpha by g, this is u square sine square alpha by 2z. Okay, maximum height. Now thus we have to calculate we calculated here the obtained value for the angle of projection when the range is equal to 3 times the height. For that case, the angle of projection becomes 53.1 degree. Okay, now the next problem is that a particle is thrown with a velocity of 5 meters per second at an elevation of 60 degree. to the horizontal. Find the velocity of another particle thrown at an elevation of 45 degree, which will have number 1 equal to horizontal range, equal to maximum height, and equal time of flight, So here again, a particle is thrown with a velocity of 5 meters per second at an angle of 60 degrees to the horizontal. And here, that is a particle here. Next, find the velocity of another particle thrown but 45 degree, which will have equal horizontal range, equal maximum height, and equal time of flight. Now that first one, the 60 degree is considered the first angle of projection, that is 60 degree. And U1 and U2, U1 is the 5 meters per second. And second particle, the angle of projection is 45 degree. What about U2? You have to find out. Here, there are three things are there, three objectives. Okay, very important here. Velocity of the second particle going to be calculated for equal horizontal range. The thing was asked here, we have to find out the velocity of second particle, which will have equal horizontal range, equal maximum height, and equal time of flight. There are three conditions. Under those conditions, we have to find out the velocities. Okay. Now, the horizontal range, we know that the horizontal range, that is u square sine 2 alpha by z. The equal horizontal range, that means u1 square sine 2 alpha 1 by g equal to u2 square sine 2 alpha 2 by g. Now, what to be found? u1 we know, but we need u2. What is the second particle velocity? Alpha 1 is 60 degrees and alpha 2 is 45 degrees. And you substitute over here, u1 equal to 5 square equals sine 2 times alpha 1, 6, sine 2 times 60 equal to u2 square sine 2 times 45. From that, u2 can be calculated. What is u2 square equal to? 25 times sine 120 by sine 2 times 45, sine 90. Sine 90 degrees equal to 1. And whereas sine 120 equal to 0.866. 25 times 0.866 by 1, that is 21.65, that is u2 square. What about u2? That is 4.65 meter per second. That is the first objective. Okay, first objective u2 equal to 4.65 meter per second, velocity of the second particle for equal horizontal range. Now, the next one is the velocity of, what is the objective here? The velocity of another particle, the second particle thrown at an elevation of 45 degree. What is that? Equal to maximum height, Now we have to equate maximum height. What is the maximum height formula? U square sine square alpha by 2z. Equate then u1 square. Then what will happen? u1 square sine square alpha 1 by 2z equal to u2 square sine square alpha 2 by 2z. Now again u1 equal to, what is it? u1 equal to 5 meter per second. Alpha 1 is 60 degree. u2 to be found. Alpha 2 is 45 degree. 2z get cancelled. When for this, under this condition, this for B objective. What is u2? u2 can be that. u2 is the constant here for the second objective. Now let us see here. The velocity of the second particle for equal maximum height. What is the maximum height? U square sine square alpha by 2z. Now equate u1 square sine square alpha 1 by 2z equal to u2 square sine square alpha 2 by 2z. Make it and substitute over here. What is u1 equal to 5? That 5 square sine square alpha 1 60 degrees equal to u2 square sine square alpha 2 45 degree. Then u2 square equal to 25 times sine square 60, 0.866, sine 45, that is 0.707. That ut square equal to 37.5. What about ut equal to 6.12 meter per second. Okay. So this is what the second condition is. Now going back for third. Equal time of flight. We have to equal again u sine 2 alpha by sine alpha by z. So what is that equal time of flight? 2u sine alpha by z. We have to equate 2u times sine alpha by z. How it comes here? Now 2u sine alpha by g. Okay, we are going to see it here. 2u times sine alpha by g. 2u times sine alpha by g. That is the time of flight. For again, we have to equate the time of flight of first particle and the time of flight of second particle. Time of flight of first particle 2u1 sine alpha 1 sine alpha 1 by g, and next t2 equal to 2u2 sine alpha 2 by g. Equate this both the time of flights t1 and t2. 2u1 sine alpha 1 by g equal to 2u2 sine alpha 2 by g. If you cancel gg, 2 and u1 equal, substitute over here, u1 equal to 5 meter per second, alpha 1 equal to 60 degrees, u2 to be found, alpha 2 is 45. Then u2 can be calculated. Let us see. Now, velocity of the second particle for equal time of flight, that is t equal to 2u sine alpha by z, equate 2u1 sine alpha 1 by z equal to 2u2 sine alpha 2 by z. Cancel whatever required, both left hand side and right hand side, gz and 2 and u1. What is that u1? Yes, got cancelled. What is u1 equal to 5 sine alpha 1 60 degrees equal to u2 sine alpha, that is 45 degrees. From that, u2 equal to 5 times sine 60 degrees by sine 45. What sine 60? 0.866. What about 45? Sine 45? 0.707. Substitute over here and calculate. The obtained u2 is 6.12 meter per second. 6.12, u2 equal to 6.12 meter per second. Okay, this is a very, very important model. It covers the concept, the complete concepts of equations of trajectory, and from the equation of trajectory, the three components such as time of flight, the maximum height, and the horizontal range, or components are involved in this. And this model is related to double projectile problem. There are two particles are there, two projectiles are there. When two projectiles with different degrees, when having equal range, equal height, and equal time of flight, then what is second particle? The particle's velocity is obtained as first case, one equal range is there, that is 4.65 meter per second. And with particle is, what is u1 here? The alpha 1 is 60 degree. If you make a table, u1, u2, u3, we are going to make it for range consideration. What is u2 and u1? Okay, we are going to make it one table so that we'll understand better, we can interpret clearly. Okay, there are three parameters are there, u1, u2, for range, equal range. Okay, for the degrees are, yes, the angle of inclination alpha for this, yes, alpha u1, u2 at alpha is 60 degree, it is 45 degrees. Okay, next one is equal height, h, and time of flight. The u1 is having 5 meter per second, 5 meter per second. The calculated u2 for 45 degrees, that is 4.65 here. Okay, meter per second. And second case is 6.12 for a hinge, meter per second. And third one is u2 is, yeah, this is 6.12. Okay, this is also 6.12. This is 6.12 for height, for equal time of flight 6.12. Oh, it is equal time of 8. Yes. Okay, here the velocity is constant for initial first particle. The first projectile is having with an inclination of, okay, 60 degrees, angle of inclination, angle of projectile. And the velocity is the same, that 5 meters per second, 5 meters per second, we maintain it. If we understand here, 45 degrees case, for equal range, the velocity, because of this 45 degrees, 45 degrees, the velocity is, what is the velocity it obtained here for range? The velocity for range, for the same range, it is 4.65 meter per second. It is low value in comparison to u1. This u1 is the particle velocity 1 and u2 is the particle velocity of the particle 2. Now the velocities are constant. If we understand here, for maximum range height 45 degree, the u2 is value is high, and time of flight consideration equal time of flight, the velocities values are high in comparison to particle 1. Okay, and for maximum height case and the time of flight, for both the cases, the velocity of the particle 2 remains the same, that is 6.12, because the angle is 45 degrees. Okay, now whereas for range it is 4.65. So these observations can be made from this problem, how the velocity, the particle velocities remain same for the cases of equal horizontal range and equal time of flights for both particle 1 and particle 2, with having a different angle of projectiles, that is 60 degrees and 45 degrees. Now the third problem, the next problem we are going to is very, very important. A projectile is aimed at a mark on a horizontal plane through the point of projection. It falls 12 meters, very, very important for examination point of view. It falls 12 meters short when the angle of projection is 15 degrees, while it overshoots the mark by 24 meters when the angle is 45 degrees. We have to find the angle of projection to hit the mark. Assume no air resistance. What is alpha here? The first case, range, if you want to reach the range, the first one is short by 12, second one is overshoot by 24 meters. That means r minus 12, another one is r plus 24. But r minus 12, the angle of inclination is 15 degree. For r plus 24, the angle of inclination is 45 degrees. Okay, then what about the range? Not range. To hit that point or range, what is the angle of inclination? That is to be. Now, there is r1, that r minus 12, that is r minus the 12, that is 15 degree. That is r plus 24, that is 45 degrees. Here the u is the velocity of the projection, alpha is the angle of projection to hit the mark. We want alpha. How to find out? R minus 12, we know the range. What is the range formulas? The range equal u square sine 2 times alpha by g. If r minus 12, u square sine 2 times alpha, 2 times, what is that, alpha equal to 15 degrees by g, 9.81. Next one is r plus 12, that equal to u square sine 2 times alpha, what is that, alpha, 2 times 45 by g, 9.81. That's second, r plus 24. Okay, let us see that r1 square, r1 equal to u square sine 2 alpha 1 by g, u square sine 2 times alpha 1, 15 degrees by g, that is r1 becomes r minus 12. Okay, that is the, then u square sine 2 times, that is sine alpha, sine 2 times alpha, that is 30 degrees by g, that final next r2, u square sine 2 alpha 2 by g. What is u square sine 2 times alpha 2 is the 45 degree here, 2 times 45 by g, sine 90 degrees equal to 1. So that is r plus 24, this is r minus 12. Now we want to reach that target, what is alpha. Then what to do? You have to divide equation 1 by equation 2, then r minus 12 by r plus 24, that is 0.5 by 1. Then find out the r, that range is 48 meters. The range is 48 meters, okay, and substitute this range equal to r equal to 48 meters, we got it. Now substitute this range in one of the equation, that's r minus 12 equal to 0.5, one of the equation, then that is r minus 12 equal to u square, what is that equation here? R minus 12 equal to u square times 0.5 by g, u square times 0.5 by g, r minus 12 equal to u square times 0.5 by g, 9.81 or 9.8, we are following 9.8. Now in this equation, if we substitute, u square comes What is that? U square equal to, that is 48 minus 12 equal to U square times 0.5 by 9.8. From that, U square equal to 72G, or 72 times 9.81. We know U square, we know R. From that, alpha can be calculated. Now the alpha is that, yes, here only we can calculate R equal to U square sine 2 alpha times sine 2 alpha by G. R equal to 48 meters. What is it? U square 72 times G sine 2 alpha by G. G get cancelled. What is sine 2 alpha? From that alpha, the angular projection can be calculated. This is what? 48 equal to U square sine 2 alpha by G. Then 72G, substitute over here, U square 72 times G sine 2 alpha by G. 72 times sine 2 alpha. Then alpha equal 2 alpha equal to 41.8 degree. Then alpha equal to 20.9 degrees. This is the angle of inclination. Okay, to hit the target range 48 meters. We calculated two things here. One is the target point, that range, even though overshoot and shot by 12 meters and overshoot by 24 meters. But what is that exact range? 48 meters. For that hitting, what is the angular projection is required? 20.9. So if you want to find out U square equal to, yes, one more thing, U square equal to 22G, what is the velocity also can be calculated, because U square equal to 72 times G, 9.8. Then what is that U? U can be the initial, the velocity, U can be calculated, is calculated here. The angle of projection is 20.9 degrees. And finally, what is the range is 48 meters. Even though this problem was asked only what is the angle of inclination, alpha. But this involves the calculation of the range, calculation of the velocity U, and finally, alpha is angular projection, that is 20.9. Okay. Now with this, we solved all types of models covered, from simple model to double particle problem, and also a single projectile, it is overshoot and undershot, and what is the angular projections. Mostly we calculated how to calculate the angular projections for the given data. Now let us go for one more, the problem, unsolved problem here. For this case, a bullet is fired at such an angle over a horizontal plane that its horizontal range is equals to the greatest height. What is for this H? What is the angular projection? And in this case, substitute what is the range and what is the height. What is the range formula expression? U square sine 2 alpha by G. What about height expression? That is U square sine square alpha by 2G. If you make it calculation, U square get cancelled. Sine 2 alpha, that means 2 times sine alpha cos alpha equal to sine square alpha by 2. Now sine alpha, one sine alpha, that is tan alpha equal to what happens? That is a 4. From that, alpha equal to tan inverse of 4, then it becomes 75 degrees 58. That is alpha, angular projection. Okay, this is the methodology here. The condition was given, horizontal range is equal to its greatest height. That's what, in this manner, it obtained the angular projection to reach the greatest height, and provided here the horizontal range and height both are same. If the range is 10 meters, height becomes 10 meters here. That's what exactly is 10 meters, then is like a 10 meters height. Okay, this is the 10 meters range, suppose R, and here it is H. Both are equal, then R equal to H condition. The angular projection, if you want to hit, that is 75 degrees 58 inches. Alright, this is in this manner we have to solve. Sometimes they will ask you horizontal range is equal to horizontal range H equal to horizontal range R equal to 3/4 of the height, or the same thing, substitute horizontal range equal to half of the height, horizontal range equal to 4 times height. The different various conditions under these conditions, what is alpha? Alpha can be calculated, substitute the expressions of range and height. Then you get directly the angular projections for those conditions. Okay. Now let us solve. We are going to go for short questions so that you can understand better. The path of a projectile is not a parabola. So answer A and B. The path of a projectile is a parabola or not? It's a parabola. The path of a projectile is parabola. Here it is saying it is not a parabola. The given condition is false. So B is correct. Okay. B is correct here. The next one. The time of flight of a projectile on a horizontal plane is just now 2u times sine alpha by z. This is the A is the answer. Here it gives 2u cos alpha by z, 2u sine alpha by 2z, and u cos 2 alpha by 2z. So if you read all these expressions, you will forget the original expression. So better whatever you know directly make it. That is 2u sine alpha, 2u times sine alpha by z. That is the time of flight of a projectile on horizontal plane. The next one is the horizontal range of a projectile is u square sine 2 alpha by z. This is the B is the answer. 3b. Okay, that is u sine alpha, u sine 2 alpha by z, no. U sine 2 alpha by 2z, no. U square sine 2 alpha by 2z, that is also no. Now, the next one is the horizontal range. The horizontal range of a projectile is maximum when the angle of projection is 30 degrees. A is A option. Option A 30 degrees, for option B 45. Option C 60 degrees and option D 75 degrees. So here the maximum angular projection takes place here the 45 degrees. Okay, horizontal range of maximum. Okay, that is the 45 degrees. When if you hit or if you throw the ball or if you throw the projectile with 45 degree angle, you reach the maximum range. That's why maximum distance. Now from where it came from, the maximum range, horizontal range are equal to u square sine 2 alpha by z. Okay, sine 2 alpha equal to 1. 2 alpha equal to sine inverse 1, 90 degrees. Then alpha equal to 90 by 2, that is 45 degrees. So alpha equal to 45 degree. How we calculate it? So then only when sine 2 alpha, sine term becomes 1, the range becomes, and sine 2 alpha equal to 1, that is u square by z, r equal to u square by g. That is the maximum range. Okay, but what angle from this? That is 45 degrees. Okay, now the next one is the maximum height of a projectile on a horizontal range is, what is the maximum height? U square sine square alpha by u square sine square alpha by 2z. This is the derived expression. Where it is u square sine square alpha by 2z, here it is. That is the maximum height of a projectile of a horizontal range. So this is the derived expression. The next objective is the time of flight of a projectile on upward inclined plane depends upon. It depends upon what? The time of flight. What is the time of flight? To u sine alpha by g. That is the time of flight. It depends upon what is the things. Okay. Here read based on the expression. This time of flight depends upon u and alpha. Okay. But what are the answers? Here A is option A is angle of projection. Okay. Angle of inclination of the plane. Okay. And they did not give you here in the options. The D is the none of the above and both A and B. Now here the time of flight of a projectile is depends upon, here we can mention both A and B. Okay. Angle of projection and angle of inclination of the plane. It is a horizontal plane. If it gives the time of projectile of an horizontal plane, here then upward, here inclined plane depends upon. Here what is the type of? It is not horizontal plane, it is on inclined plane. So both inclined plane and also angular projection alpha. The next final objective is that the range of a projectile on a downward inclined plane is the range on upward inclined plane for the same velocity of the projection on an angular projection. Here there is the less than the range or equal to or more than. So we can see it's the more than the range of upward inclined plane for the same velocity of the projection and the angle of projection. Okay, with this we can understand we covered here what are the things we covered. In this session we solved the problems by we derived the expression first maximum height, that is u square sine square alpha by 2z, and we solved the problems. We solved the single projectile problems, double projectile problems, and calculated angle of projections. What is the angle of projection based on the given conditions, and also we discussed short answer questions. Okay, based on those expressions we can solve directly. Okay, and finally the references were followed in this session. These are the references were followed, and most of them is the reference one is covered. Okay, and also followed that Irving, H.M.'s, Hibbeler, and also Beer Johnston. These are the references are followed and cleared the concepts and explained and described in this session in briefly. Now let us, we can say thank you for this session.
Like, share and subscribe. Hit the bell icon for more updates.